Case study 1.5, calculating global energy and power consumption now and in the future, represents not only an extremely important way of calculating energy and power now and in the future, but it also represents something very important about these case studies. And that is that there are various ways of doing a calculation that simplify the calculation and yet maintain accuracy. And this is an example that we will watch very closely here in case study 1.5, because we want to calculate global scale energy and power consumption. And when we do that, we want to focus on the total global primary energy consumption. That is referenced as TGEC in the lingo. And when we look at the calculation of total global primary energy consumption, there's one way of doing it is to take the 7 billion people that occupy the face of the earth and go around and ask every single one of them what's their energy and power consumption. Well, that would take a long time. So the question is, how can we do this accurately that reflects not only the case now but also decades into the future? And when we do that analysis, it turns out when we think about it, it's going to be proportional to population, which we'll call POP. But it's also a function of per capita income, it turns out. Now, that's not an obvious point, but it turns out to be extremely robust when we're doing the calculation, because the final quantity is the primary energy intensity. And that means that we can calculate the total global primary energy consumption as a product of population times PCI times PEI. And of these, the population is probably the most obvious. The most subtle of these is the per capita income, because it's not obvious at first blush whether per capita income is really the quantity of concern, but it turns out to be very accurate. Now, primary energy intensity, that is the amount of energy required to produce $1 of GDP, that's fairly obvious, and it's also very accurate. So it's these three quantities that we want to look at when we're calculating global scale energy now and in the future. So let's take a look at an extremely important plot. We're going to look at this first quantity, global population. So modern humans emerged from Africa about 160,000 years ago. And a key point is that during the Roman period, the total global population was 250 million humans. And an easy way to remember when global population reached 1 billion was the year of the American Revolution. Total population reached just over 2 billion at the point of the Second World War. But in 2006, 6.5 billion, but it's headed for 10 billion people in 2050. So that's the plot of global population versus time over the centuries. So now let's look at energy required to sustain this population. When we look at the energy required to sustain this population, it's very important to look at the recent results from the United Nations that examines the evolution of human population with time. But it breaks it down into that population from Asia, Africa, Latin America, Europe, North America, and the ocean island communities. And the remarkable thing to notice here is that while Asia is recognized as the area of rapid population increase, the change in the Asian population from 2018 to its peak at about 2050 is only about 0.4 billion people. But look at Africa. Africa is about 1.2 billion today, but it's headed for 3.6 billion by the end of the century. So the dominant increase in population is occurring in Africa. Now what's interesting about this is that we learned directly from the shift of population in Asia from the rural to the urban was that a rural citizen consumes about 200 watts of power. That is, day in, day out, 200 watts. The moment that person moves to the urban area, that power consumption per capita goes to 2,000 watts. And just to show you how this fits in with the rest of the world, Western Europe, each man, woman, and child consumes about 550 watts. And in the United States, every man, woman, and child consumes 10,400 watts. But it's that conversion from rural to urban that is driving the dominant increase in global energy consumption. So population is important, but it turns out the more sensitive factor is the shift from rural to urban as it drives the global energy consumption. So when we put these numbers together, look at what happens. This is the increase in population, as we talked about before. This is the increase in global energy. It skyrockets up to nearly 40 terawatts, 40 times 10 to the 12 watts from the current level. It's about 15 terawatts. So looking at this requirement for energy to sustain the population in the urban areas as the population shifts from rural to urban turns out to be a crucial part of this case study.